We're finishing off this unit. We've been talking about position, velocity, acceleration, by just like finding interesting values of positions, velocity, accelerations, max and min values, average values, okay? And after this, we will be able to do any free response problem involving straight line motion. Your test in 2 classes, all free response, okay? So start with finding max min values of position, velocity, acceleration. Well, let's just remind ourselves, how do we find max mins of just like F? No, but you could use it. But let's recall unit 3. If I asked you, hey, here's F, tell me when F has relative extrema. Yes, we would look at the derivative, okay? Because the derivative tells us if something is going up or down, and we're going to do a sign analysis of the derivative. The most important thing that you need to remember from this class, like overall, there's one thing you're going to remember after all year. You're going to remember that if you want to find a max or min of something, you take the derivative and set it equal to 0. Okay? Just remember that. If there's ever like a problem that you don't know how to do on the AP exam, take the derivative, set it equal to 0. Give it a shot. You know, maybe that'll work. Okay? So you'd find F prime, you'd set it equal to 0, you then do your fancy sign analysis. And let's say you got like 1 and 2 here, and you got F prime is positive, negative, positive, and that is telling you that F is going up and down, then up. You know that 1 is the location of a max. You know that 2 is the location of a min. Okay? Well, if I asked you to find the relative extrema or like maxes and mins of velocity, take the derivative, set it equal to 0. I don't actually care that the derivative of velocity is acceleration. I don't. The derivative of velocity will tell if velocity is going up or going down. So I want you to find the max v. It's just like finding the max f. Take the derivative, set it equal to 0. Solve, do a sign analysis. V prime will tell us if V is going up or down. Is V prime A? Sure. Sure. Doesn't matter in this situation. Positives, negatives, positives. I'll have a max velocity value at 0. I'll have a min velocity value at 1 because V is going up in its values and going down and going up. Okay? So, how do you find a max position? Take the derivative, set it equal to 0. How do you find a max acceleration? Well, get an acceleration function, take the derivative, set it equal to 0. Okay? If you need to like underline this take the derivative, set it equal to 0, put stars or happy faces around it, please do so. Okay? Because it's very, very important. Now the question though, and that's just review, but if the lesson was just that, I would be like, you know, we're wasting our time because we've already known this. The question we are going to deal with, which makes today's lesson a little bit different, and it can be applied elsewhere, is are these the overall maxes or mins? So not, oh, at a location, I have just a little hump, you know, that's a max, that's a min. The question now is like, if I look at the entire equation, is that an overall max or an overall min? Okay, please discuss that with your neighbors. Could we say those are the locations of overall, like Bigger, it's going to produce bigger values than anything else, or smaller values than anything else? What do we think? The answer is no, but why? It's exactly right. If we are coming up and then going down and ending up, well, like, I'm going to go towards infinity. I'm going to go towards negative infinity. Okay, so these are not the overall maxes and mins. Well, what we won't do is well, rarely will we be asked for an overall max and min over an entire, like, from negative infinity to infinity, over an entire graph. So to counter this, so that we do have an answer, and the answer is not infinities, you will be given a interval, say from here to here. Okay? Now, where, and it's maybe tough if you look at my graph, please tell your neighbors, where is the overall max and overall min if I just looked at that portion of the graph? Go.
Just based on your graph alone?
Just based on my graph alone. We have a situation where, okay, the max is where my relative max is. That, I didn't say that was the overall max, but if I shrink the graph, I say, oh yeah, there you go, there's the overall max. Is this the overall min though? No, this endpoint is the overall min, okay? We'll come back to finding the overall max and min for this situation later, so we'll come back to this. Instead, we'll talk about the concept of the extreme value theorem. If I don't look at an entire graph, if I look at an interval, a closed interval, where will I find overall maxes or mins? Discuss with your neighbors. But where will that always occur? Either at a relative max or a relative min, or an endpoint. That's the answer. Okay? On a closed interval, absolute extrema occur overall maxes and mins occur either at the location of a relative extrema we know to find a relative extrema, you take the derivative, you set it equal to 0, you then do your sign analysis. Or an endpoint. Okay, so for example, I had a minimum value at an endpoint. Well, maybe I look at this graph from 0 to 3. Here, the minimum is at the relative min. This is a relative / absolute min. But here, that would be my absolute max endpoint. Okay? Now, the question becomes like, well, if I don't know what the graph looks like, I just assume the graph kind of looked like this. But maybe we have a situation where I go up, go down. What am I trying to get to? Yeah, maybe I have a situation like this where I end up going up and then down. I don't know which endpoint is going to be the minimum or which endpoint might be the maximum, okay? Let's take the situation we just had, okay? Is 0 and 1 our overall maxes or mins? All right, well, so we already did V prime. Instead of looking overall, so from negative infinity to infinity, let's look from just 0 to 3. So all of a sudden, my sign analysis, I want to kind of shrink a little bit. And I see that I had 1. And V prime was negative and then positive. By looking at our sign analysis, we are able to tell definitively where one of our absolute or maxes or mins are located. Okay? Discuss with your neighbors. Do we know for certain where your absolute max or min is for V over this interval? I know for certain one of the two. Which one? Which one do I know?
0 to 1.
0 to 1, what happens? So I don't want to say 0 to 1 an interval. I want to say at a point I have a min. At 1, right? At 1, I know for certain this must be the location of the absolute min on the interval. Because I know V must go down and then go up on the interval. I can go ahead and find that value if I want. The absolute minimum value, you would take 1 and plug it into V, not into V prime, because V prime at 1 is going to be 0, but plugged into V, I get 2 minus 3, which is negative 1. Okay. Which one's my max, at 0 or at 3? You don't know. That's exactly what you need to say. You do not know how far you go down from 0 to 1 and how far you go up from 1 to 3. So right now, the absolute max is, skip it on me, is unknown. What we're going to do is we're going to say, hey, we don't know, but we have two possibilities. We know it could either be at 0 or at 3. How do we know which one's going to be bigger than the other? Well, we could literally just plug in 0 and plug in 3 and find the values and compare them. We have limited our potential locations of maxes to just 2 candidates. We can compare the velocity values of those 2 candidates. Plug in 0 into V. Remember, V was 2t cubed minus 3t squared. V of 0 is 0. V of 3 would be 27 times 2, which is 54, minus 9 times 3 is 27, so that's 27. So I do know that my absolute max is actually going to be at 3 because of what I just did, which is called the candidates test. Okay? Here's the candidates test. If you're asked to find absolute extrema, you're going to take the derivative and set it equal to 0. This whole process is finding the relative extrema. Take the derivative, set it equal to 0. Do a sign analysis. Identify your candidates for maxes or mins. There may only be one, which means you're done. Just like we knew we had a min. If there's more than one, if you have 2, which is probably your other situation, you could have more than 2 though, but more than one candidate, just compare their values, because it's like, I already know it's like between these two, plug in the t values into the original equation and compare values. Compare values if more than one. So you found the relative extrema, and then this is what we call the candidates test. Okay? Now, you will not be asked questions, find the absolute max, find the absolute min of this. Because we're talking about position, velocity, acceleration, they're going to word the questions a little bit differently. This question is worded, here's the position function, when is the particle furthest to the left? Okay? Now, we think of being to the left. What kind of values do you have for position as being left? Negative. Negative positions are like to the left. But obviously, like I could start at a position that's positive. I can move to the left to a small positive position and then move back to the right. Well, that's still when I'm furthest left. But no matter what kind of situation you have, something is furthest left when the position is at an absolute min. This is very important. You read furthest left, you think, what is the smallest position value I can get? So I changed this question from furthest left to, oh, what is the absolute min of position? How do I find a min of something? Everybody is going to say it together. How do I find the max or min of something? That's beautiful. Beautiful. Take the derivative. I get x prime. Is it v? Yes. Do I care? I actually don't care. I mean, it actually helps me understand my answer because I'll understand v means like I'm going left or right. But I'm just going to say I have x prime, the derivative of x. X prime is telling me if x is increasing or decreasing. We're using this equation a lot today. Sorry, that's 16. 0, 1, I'm going to 2. I don't care what's going on to the left of 0, to be honest. Plug in something greater than 1, I get positives. Something a little bit less than 1, I get negatives. Where are my candidates? Do I have to compare values? Discuss with your neighbors, please. Since x prime is negative, then positive, x must be going down, then up. I must be furthest to the left at t equals 1.
Oh, that's all you have to do.
Question?
Why would position 0 be furthest to the left?
Because I travel to the left from 0 to 1.
That's the derivative.
X prime, the change in position, my position is decreasing, so I start at 0, but then my position values decrease, which means if I start at 0, I'm going to the left. I actually don't start at 0, I start at a position of 2 when t is 0. Now notice, we are not like plugging in values just randomly into x. That's not how you do things with calculus. So when we're doing our free response problems, never plug in like 1, then 2, then 3, then 4, and just like look at the values. Not going to work. That's not a satisfactory answer on a calculus test. Okay, but then the question, and we could actually find this position, the value, by plugging in 1 into x, 2 minus 3 plus 2 is 1. Negative 1 plus 2, yep. What is my particle furthest right? Is that 2? Is that 0? You don't know, so please, this is a situation where you have more than one candidate. First one, you only have one candidate. It's definitely going to be at 1. For the furthest right, you have 2 candidates. Not going to be at 1, I know that. It could be at 0. It could be at 2. In the last situation, we thought it would be at the right endpoint. Let's see. Is it at the left endpoint here? 16 minus 12 is 4, plus 2 is 6. So no, it ends up being at the right endpoint here as well. This one works. Okay, you see that process? It's not hard. Just make sure if you don't know if it's at a possible endpoint, you got to check. Now there are situations where, I'm going to skip this one and go here. Change this from maximum acceleration to maximum velocity. Okay, what is the maximum velocity? This question is asking when are we moving fastest to the right? Good beginning, Mr. Butcher. If I ask you to find a max v, what do? Take the derivative, set it equal to 0. Please change your velocity to my velocity for reasons I will show you in a second. Okay, please, everybody, take the derivative of that v equation and set it equal to 0. Hold on. I want to make sure I got this right. Make sure this is a that's a positive 2. This is a negative. What? I took the derivative and I'm like, wait, I need these answers to look like this. The only way it can look like this is to have it like that. So yes. I saw into the future. I looked into the future and realized my equation needed to be different. This will work. You do this enough, you kind of figure it out. This is like my 7th year, I think, 8th year.
No, it's not that
You teach BC at all? I taught BC for 2 years. Yep.
Was it fun?
No, it's just there's more AB sections, and I don't want anybody else to teach AB. AB is my class, you know? Yeah.
Feet all over it.
It's okay. We're recording this. It'll be fine. All right. So there's the derivative. Please set that equal to 0. So like I gave you velocity, I asked you for the max velocity, take the derivative velocity, set it equal to 0. I'm looking from 0 to 3, and I got 1 and 2. Okay, go ahead and do your sign analysis, please. What do we get? Positives, negatives, positives? 2 to 3 are positives, 1 to 2 are negatives, 0 to 1 are positives. Please discuss with your neighbor. Do I know right off the bat where my max is, or do I not? And if I don't, what are my candidates? I know for certain it's not at 0. I know for certain it's not at 0. If V prime is positive, V must be going up. So it's not at 0. V of 1, I know for a fact, is bigger than V of 0. I know for a fact. I know V of 2 is smaller than V of 1. I know V of 3 will be bigger than V of 2, but I do not know if V of 1 is bigger than V of 3 or vice versa. Because of this, I have 2 candidates. Okay, which one produces a larger velocity value? Don't guess. You're going to have to figure it out by comparing values. You only have 2 candidates, but this is when you have to actually like plug some stuff in and figure out which one of your 2 candidates produces the larger value. V of 1 is 1/3 minus 3/2 plus 2. That's 2/6 minus 9/6 plus 12/6. So that's 3/6 plus 2/6 is 5/6. Why does it keep jumping on me? V of 3 is 9 minus 27/2 plus 6. That's 18/2 minus 27/2, which is minus 9/2, plus 12/2, which is 3/2. If you guessed, you got lucky.
Like educated guess. I like.
Be careful. I mean, I've set this up purposely so it's only like 1 second, 1 second, 1 second. Some of you might be like, oh, it's going to end up at the same location because it's like decreasing then increasing over 1 second. You don't know the rate at which you're decreasing. You just know you are decreasing. You know you are increasing. Turns out we will increase faster from 2 to 3 than we decrease from 1 to 2. Okay? So that's finding absolute maxes and mins. One thing I need you to be heads up, go to the previous problem. If I give you position 2t cubed minus 3t squared, x of t is 2t cubed minus 3t squared plus 2. And I ask you, when are you moving fastest to the right? Would I take the derivative of position and set it equal to 0? No. What do I have to do? No. No. Take the derivative of the derivative. I would need to first get a velocity function. And then, fastest to the right would be the max of v. Take the derivative of v, set it equal to 0. Does that make sense? So, like, I say to find a max or min, take the derivative, set it equal to 0. Make sure you're taking the derivative of the correct function. Whatever you're trying to find the max or min of, you take the derivative of that. I didn't start with that. So I took the derivative to get that, and then I took its derivative to set it equal to 0 to find the max or min. I won't go through the process of doing that. We'll move on. Okay? Trig functions are in play. You guys remember how to solve this? When sine t minus cos t equal to 0? Two ways to do this. You can move it over, divide, so that you end up with a tangent equal to 1. Or you could say, I need my sine value and my cosine value to be equal to each other, so that when I subtract them, I get 0. When does that occur? Pi over 4. As well as 5 pi over 4. Now, I don't have to worry about 5 pi over 4 for this situation, because I'm just looking at them from 0 to pi over 2. You will have a homework problem similar to this, but using ease, it's a tough one. You have to try it. Now, furthest left, position is a min. I'm hoping that I don't have to plug in values, but maybe I do. Let's see. Pi over 4 to pi over 2, plug in something like 2 pi over 3. Okay, sine minus cosine. The sine of 2 pi over 3 is root 3 over 2. Root 3 over 2 is bigger than a half. This is a positive. Pi over 6 is between 0 and pi over 4. Sine of pi over 6 is 1/2. Cosine of pi over 6 is root 3 over 2. 1/2 is smaller than root 3 over 2. This is a negative. Do I have two candidates that I have to plug in values for? Or do I just have one, which I'm thankful for, and I'm done? Just one. Because x prime goes from negative to positive, I know I'll have my absolute min at pi over 4. Okay? So that's like a little bit of a review of some trigonometry stuff, which you will have a no calculator question involving trigonometry. I'll tell you that right now on your test. Singular meaning one of the 5 free response questions. Please put your phones all the way away off your desks. All right, moving on. So we find maximum and min values. The last thing we're going to do is find average values. Now we're going to skip this first kind of introduction. I'll go back to it, but I don't love it. I'm still going to go here. So flip the page. We've already found averages. Like I asked you to find the average velocity. Please look on the first page of your note packet. How did we calculate average velocity? Oh my goodness, you don't even need the notes. Very good.
Is it actually zero?
Yes. Yes. Redeeming ourselves from the P commentary. Slopes of position give us velocities. To get an average velocity, I would get, and I would use, an average rate of change, a secant slope of position. We talked about average rate of change being slope of secant, so it's a y2 minus a y1 using position over x2 minus x1. And this is great. We can use this. If I have x. But here's going to be our situation. This is not very quick to do. Sometimes it involves a lot of calculations, even with a calculator. And sometimes you're going to be given v, and you can't anti-derive v. So if I ask you, here, find the average velocity. Here, I'll give you velocity. You can't anti-derive it. Now, please don't try to like plug in values into velocity and divide it. Okay, like you know how to take averages. Okay, it's not going to work. It's not going to give you the right answer. This is a different thing. We need a position function, but I'm saying you can't find the position function. There's another way to get this same answer, and it has to do with what we know is equivalent to that, and the fact that we can use our calculator. Let's think about that, x of b minus x of a. An ending position minus a starting position. What is that?
This area.
No. Displacement. Displacement, that's one way to calculate displacement. The other way to calculate displacement is by thinking of velocities times times, or the visual representation of that is our area under our velocity curve. So we can use an integral which your calculator can calculate, because this is equivalent to this. And just divide that by b minus a, and you're good. I like to write it like this, 1 over b minus a times the integral of a to b via t dt. This gives us my average velocity. Notice, velocity is in the integral, the area under velocity. Use it. Now, we talked about the slopes of velocity give us accelerations. If I wanted to find an average acceleration, so let's just change this. This is v, slopes of velocity gives us a. If I want to find the average acceleration, I could give you the average rate of change of v, and that'll give you average a. This will be v of b, this will be v of a. This turns into a. So, okay, if I want to find average a, I need a in my integral. What do you think would need to be in the integral if I wanted to find an average position? X would be in my integral. The area under my position function would give us the average position. As long as I multiply it by 1 over b minus a. So, in general, what we'll say is you want to find the average of something, find the interval in which that something is taking place. That's like the change in the time. Multiply this 1 over b minus a times your integral from a to b of that something. Okay? Quick examples. Average position from 1 to 4. Oh, 1 over b minus a, integral from a to b of, okay, I get position, plug in position. If you have a calculator, plug that in, piece of cake. Average velocity from 2 to 4. 1 over b minus a, integral from a to b of, well, I just need velocity in here. 3t squared minus 6t. Great. You can plug this in to your calculator and calculate it. Average acceleration. Well, 1 over b minus a, integral from a to b of a, 6t minus 6. All I ask is that we be careful. If we are to take and find an average without a calculator, let's say I give you velocity and I ask you to find the average position. Okay, let's just go straight to the bottom one. I was told that my velocity is 2t minus 5. My initial position is 1. And I ask you to find the average position. Well, what's very important is that you need in your integral, 1 over b minus a, integral from a to b, the position function. When we take the antiderivative of velocity to get position, we have t squared minus 5t plus c. A lot of times when we're using integrals, we know that the c will get crossed out. This is not one of those times. I need the entire position function here. I need to first find c using the initial condition. I find that c is 1. I need to then make sure, if I were to do this without a calculator, that I would find the antiderivative of this to evaluate this without a calculator. So I get 1/3 times the antiderivative and the change in this between 0 and 3. You'd have to do the calculations by hand and then multiply by 1/3. What's great about this is that you can find the average of anything, whether it's just like f. Average f, 1 over b minus a, integral from a to b of f. That will find you the average f. It would be the average rate of change of big F, but it ends up being the same thing here, okay? So that's average values. Your homework has lots of free response. We're getting ready for our test, which is all free response. Thank you.